Hello, this is Dr. Mears, and today we are going to be going over complex numbers. This is the complex numbers review. A student asked if I could go through the answer key for this review, and I'm going to. What I have done is I did the review out, so I'm not going to be writing. I'm just going to be reviewing the answers and talking through the problems. Hopefully that'll make it not as long as it would be if I was going to be writing. So let's start. First, we're going to have to be able to simplify radicals. The first radical we have here is the square root of 343. So what we're going to do is we're going to break this up. The first one has to be a perfect square. And the second one has to be what we multiply to get back to that original number. And please make sure you put these square root symbols. A lot of people forget to put the square root symbols and they just disappear and then the answers aren't represented correctly. So we have the square root of 49, that is a perfect square, times 7. 49 times 7 gets you back to 343. So then we're going to take the square root of 49 and we get 7. And we're going to bring down the square root of 7. That arrow just does not look correct there. So square root of 49 turns into 7. We bring down the square root of 7 because we cannot go any further. So this is 7 times the square root of 7. So that's what this radical is, simplified. Let's look at the square root of negative 18. Because we have a negative, we have an imaginary unit or imaginary number. So what we're going to have to do is we're actually going to break this up 3 times, in which you previously saw. We have the square root of negative 1, the square root of 9, and the square root of 2. This is all multiplication because we have to multiply. Negative 1 times 9 times 2. If we put that underneath the square root, we get back to negative 18, and that's what we want to get back to. I just separated them so that we can rewrite the answer, remembering I equals the square root of negative 1. So let's rewrite this answer. The square root of 9 comes down as 3. The square root of negative 1 comes down as I, and we cannot go any further with the square root of 2. So our answer is 3i times the square root of 2. All multiplication, that's why you don't see any other operation except them all together. Okay, number 3 and number 4. Number 3, we have the square root of negative 96. Again, we have a negative underneath the square root, so it is imaginary. So we're going to do negative 1. The highest perfect square is 16. 16 times 6 does get you back to 96. So we're good there. And so the square root of 16, 4. The square root of negative 1, I. And then we just bring the square root of 6. That's always last. Square root of 6. All multiplications, so our answer is 4i times the square root of 6. And the last one, we have the square root of 27k. So the perfect square that can be divided, 27 can be divided by is 9. 9 times 3k, we cannot do anything with this k, so that's just underneath with 3. Square root of 9 is 3, and then we just bring down the square root of 3k. We cannot go any further with this, so we just bring down square root and all. So please do not forget those square roots, and please, if you do take the square root of a number, such as a square root of 9, that square root disappears. It's a very common mistake I see with keeping the square root or not keeping the square root. So if you can take the square root, the square root symbol disappears. If you can't go any further, the square root symbol stays. Okay, that's some simplifying radicals. What do we have next? We have simplify. Ooh, and we're looking at complex numbers. So here we go. First, what I do need you to realize is that our I squares, remembering I squared equals negative 1. So if you want to write some of this down, I equals the square root of negative 1, and that is a terrible I squared. I squared equals negative 1. So when you square it, remember that square root goes away. Okay, so first look to see what operation separates these. Do you see how all of these parentheses are together? There's no addition or subtraction in between. There's no division sign. So this means multiplication. So I need to multiply all of this. The first thing that I multiplied is just that I times 6i. So I times 6i, as you see over here, is 6i squared. This I squared is -1, so this was really 6 times -1, which gave us that -6. That's how I got that -6. So then I brought it down. So this piece became -6. I brought the 4 minus 3i down, and then I used the distributive property. -6 times -4, -6 times -3i. I got 24 plus 18i. I cannot go any further, and so that's where I stop. Number 6, we have the quantity 3 plus 7i squared. Now be careful because you're not distributing this. You need to rewrite it. The square means times itself. So we have 3 plus 7i times itself. So that's 3 plus 7i times 3 plus 7i. So I'm going to now multiply. First I did 3 times 3, that gave me 9. 3 times 7, that gave me positive 21. Then I did 7i times 3. Oh, sorry, I forgot the I. 3 times 7i gave me 21i. Then I did 7i times 3, another 21i. 7i times 7i, 7 times 7 is 49. I times I is I squared. Now let's combine like terms, and we are going to have to change that. So in combining like terms, 21i and 21i give me positive 42i, brought down by 9. And then I change, because this is a positive 49i squared, it changes just to negative 49. Please notice, once that sign changed, there's no more I squared. It disappeared. I can keep combining because I can do 9 minus 49, and that 9 minus 49 gives me negative 40 plus 42i. And that's it. That's how you write your answer. Okay, our next two, number 7. And now let's notice, again, multiplication is here. There's no addition or anything. We're going to be getting to that, so you have to notice what operation you're doing before you can do anything. So there's multiplication. So I times negative 6i, negative 6i squared gives me a positive 6. So this was negative, changes to positive, no more I squared. All right, so I brought that down, 6. So that was from this piece. I brought down the negative 3 plus 3i. It's multiplication. So let's distribute. 6 times negative 3 is negative 18. 6 times positive 3i is a positive 18i. So it's negative 18 plus 18i. Okay. Number 8. Let's notice, and I underlined it here. What do we see? We see a plus sign. So we're not multiplying. We're just combining like terms. Because this is a plus and because there's no number right here, it's really 1, what we can do is just remove the parentheses. So all I did was I removed the parentheses. I have negative 3 plus 2i plus 5 minus I. Notice there's just no parentheses. Because I'm adding, we can do that. Let's combine like terms. Negative 3 plus 5 gives me 2. And I brought down my 2i. I brought down my minus I. Combining 2i minus I gives me I. 2 minus, this is really 1. So 2 minus 1 is 1. And bring down my 2. So 2 plus I. That's it. So this was addition. Combining like terms. Okay? So we have to be careful. All right, number 9. And I even put little arrows, addition arrows, addition arrows. So this is not another addition one. So because it's addition, we can remove our parentheses. Oh, there we go. Okay, so 8i minus 6 plus 7i plus 8i. All I did was I removed my parentheses. This plus or minus just becomes minus. Then I'm going to combine like terms. My 6 is erasing here. 8i and 7i, 15i. I brought down this. I brought down my negative 6. If you want to combine like all of these, 8i, 7i, and another 8i, that's fine. It's going to come out to 23. We have 8 i's, 7 i's, and 18 i's. Together we have 23 i's. It's fine. We have no other common term with -6, so I just brought that down. So our answer is -6 plus 23i. Okay, number 10. What do we notice here? No addition or subtraction or division. Multiplication. So the first thing I did was I multiplied 3i times -6i. I got -18i squared. Changed that to +18. This dropped out. Brought down my 7 plus 2i. And now I'm going to do some multiplication. 18 times 7, 126. 18 times 2i, +36i. Here's my answer, 126 plus 36i. Moving on to the next set. Okay. All right, we have a couple different things here. You notice you see this minus sign here, but what do we have to do first? Multiplication, division. We still follow the rules. Parentheses, exponents, multiplication, division, addition, subtraction. So we have, if we just look before that subtraction sign, we have a multiplication problem. After that subtraction sign, we have another multiplication problem. So we need to do these multiplication problems first before we go anywhere with this minus. Okay, so this is first, number 1 and number 2. All right, and then we can combine with number 3. All right, so what did I do first? I did I times -4, -I times -4, +4i, -I times +2i, -2i squared. Okay. Then I did -I times -6. I took that as a negative. Okay, that's why we didn't really, this is not even going to be, step 3 is going to really combine like terms. So -I times -6 is +6i. -I times +8i is -8i squared. So I treated these like two different problems in one. Okay, let's simplify. We can change some of this, as you can see. I have 4i, brought that down. This changed to +2, brought the 6i down. This changed to +8. You see that I'm starting to combine. 2 and 8 gives you 10. 4i and 6i gives you 10i's, so 10 plus 10i. So I really didn't do too much with this subtraction. I just kept it with the second problem as a negative I, and it took care of itself. It worked itself out. So there was really 2 multiplication problems in here. Okay, number 12. What do we see? Multiplication. Perfect. Okay, let's multiply. 2 times -3, -6. 2 times 3i, 6i. 6i times -3, -18i. 6i times 3i, +18i squared. Bring down the -6. Combine 6i minus 18i gives you -12i. Change this to -18. No more I squared. Combining like terms, -6 minus 18 is -24. Bring down my -12i. Okay. Next set and our last set. Simplify the following complex conjugates. So I'm thinking we're dividing here. Oh no, we're simplifying. Just simplify the, I'm thinking we're multiplying here. Okay. So first, complex conjugates. Remember, we got A plus BI. We're going back and forth, A minus BI. So we're going to be multiplying that. So we have -3 plus 4i, -3 minus 4i. There is a short way to do this. I'm going to do it out the long way just so that you're used to it. But if you start to see the shortcut, you're more than welcome to use the shortcut. All right, so I multiplied -3 and -3, -3 and -4i, 4i and -3, 4i and -4i. The middle cancels out. I bring down my 9. This changes to +16. Now, if you saw -3 times -3 is 9. 4i times negative 4i is negative 16i squared. You can jump there. You could. But just be careful because if they're not complex conjugates, it's not always going to cross out. So it only works for complex conjugates. Okay, number 14. Complex conjugate, negative 1 plus 7i, negative 1 minus 7i. Yes, okay. Multiplying it out, negative 1 times negative 1 is 1. 7i times negative 7i is negative 49i. So it's 1 plus 49, which is 50. Perfect. And this was 25. I'm not sure if I showed you that answer. 9 plus 6. Okay, next. 7 plus 6i, 7 minus 6i. I always like to make sure they're complex conjugates. I just check. That's why I did that. 49 minus 36i, so 49 plus 36, 85. Complex conjugates, 2 minus I, 2 plus I, yep. 4 minus I squared. This is really a 1, remember, so it just gets changed to positive 1, so 4 plus 1 is 5. And there you have simplify. Okay, now we're on our last step. I thought on our last one. Our last one's to simplify. And so now I'm thinking we're probably going to divide. Here we go with the division. Okay, so we have to simplify. So multiplying by the complex conjugate of the denominator. So this is a positive 2i, so we're going to multiply numerator and denominator by negative 2i. So when I do this, I'm just going to show you the whole thing. 6 times negative 2 is negative 12i. 2i times negative 2i is negative 4i squared. Negative 4i squared changes to positive, and I reduced negative 12 divided by 4 is negative 3. Don't forget to attach your I. You got to attach it because it is everything's multiplication here. Number 18, we have our denominators negative 10i, so I'm going to multiply numerator and denominator by positive 10i. 2 times 10i is 20i. Negative 10 times positive 10, negative 100. And this should be I squared. Forgot my I squared. I times I squared. Negative 100 I squared changes to positive 100. So I have 20i over positive 100. I'm going to reduce. I'm going to divide both of these by 20. I'm going to get 1i over 5. And I'm going to write that as I over 5. So that's our final answer. Okay. Number 19. And I did some extra work here. I think I might just, I'm going to show you this and then I'm going to reveal the whole answer. So we have to take the complex conjugate of negative 5 minus 10i. So it's going to be negative 5 plus 10i, negative 5 plus 10i. So we're going to have to multiply both numerator and denominator. So this is a little bit longer. So I'm going to go like, okay. So you're going to see work that I've done over here. So first I just did 8i times negative 5, which gives me negative 40i, and then 8i times 10i, which gives me 80i squared. And then I just rewrote it as negative 40i minus 80. Okay. To get this 125, you're going to look over here, this work over here. I multiplied, and so I multiplied my conjugates, and I got 125. So this answer just came down here as 125. All right. And then I rearranged it. So I have negative 40i minus 80, because this was positive I squares, went to minus 80 over 125. I rearranged it so it's negative 80 over 125 minus 40i over 125. I see that I can divide everything. I believe it's by 5, and so I just divided everything by 5 to reduce it. And so I reduced the answer, and here's my final answer. Okay, let's go to 20. I'm going to go like this. Here's 20. We have negative 1 minus 10i, so negative 1 plus 10i, negative 1 plus 10i. Again, I distributed this, negative 8 plus 80i. I did this work over here, and I got the answer as 101. I dropped the 101 in the denominator. I then separated it, negative 8 over 101 plus 80i over 101. And I cannot reduce that any further, so this is the answer. And I'm gonna put a little box around that answer there too. Okay, I couldn't reduce that. I could reduce this one, but I can't. There's no number that we can divide by. All right, our last two here that you'll see, number 21, we get a little bit more complex. There's a little bit more work to do. We have negative 7 minus 5i, so to multiply by negative 7 plus 5i, numerator and denominator. I did the work over here. Here's the numerator's work. Right, here's the numerator's work. 57 minus I. Here's the denominator's work. Right here, denominator's work, I got 74. 74, so you can see all that work done out. And I separated it, 57 over 74 minus 9i over 74. I can't reduce it, so that's my answer. All right, and our last one, 22. Let's look at the denominator, negative 9 minus 7i. So let's multiply negative 9 plus 7i, numerator and denominator. Again, work is over here for the numerator. I got negative 47 plus 51i. I put it in the numerator. Work right here for the denominator. I got 130, 130. I separated them, negative 47 over 130 plus 51i over 130. I can't reduce, so I leave it, and that's my answer. So this has been your complex numbers review before your performance that is coming up. I really hope that it helped everybody. Talk to you soon.